Vasundhara, like on private chat, I have pinged you one error regarding the sum of digit when we are doing with the help of reinterpret as. Can you please check it once?
Yeah, 1 minute. Sum of individual digit. Okay. Vector sum. You are using real time like 4.25 or 4.5 or something, right?
Yes, I'm using
Mm.
that only.
Yeah, yeah, okay. So vector sum reinterpret as decimal one. Reinterpret as
Even like in output DML, I tried to give decimal of 1 instead of decimal of slash n. In that case, also the program is getting fail for the same. But yeah, one point. When we are taking decimal of 2 in the
problem is this
format,
thing that you are taking this in the reinterpreters decimal one is there, but this vector is there now that is empty
yeah,
length.
so yeah, Vasundhara, if you can see in that, I have commented above one let decimal of length, string length
Hmm.
in dot num. So
Hmm.
when I use that function and keep length into that, so it is giving error as maybe I can do it. Just a minute, my laptop is open. I can show you the entire
Hmm.
what is. Uh, I'm giving you the snippet, what error it is giving.
Okay.
I have sent.
1 second. Okay. So do one thing. This num is there now. How much is maximum length? 1 minute. Your data is there. Input data. Where is this? Is the data. So 1, 2, 3, 6 is the maximum length, right?
Yes, yes.
So take a 6 instead of len. Take a 6 and that in dot num is there now. Pad it with the decimal padding with make it 6 length long. Padding some zeros.
Okay.
Instead of len, just put 6 and that in dot num, instead of in dot num, give a padded one decimal, left pad or right pad, whatever, with zeros,
Okay.
make it 6 long.
Okay. Okay. Let me try that. So in that reinterpret as only I have to do, right? Decimal in dot pad.
Mm-hmm. Yeah, like just a minute. You are using reinterpret as, then decimal. This one here you give 6,
Yeah.
and this in dot num is there. Instead of that you give decimal.
Helpad.
Yeah. 1 second. This comma 6 length long paired with 0,
0. Okay.
like this.
Let me try.
Performance. Where is that? Okay, we'll complete today's and then we'll discuss about the performance. I don't know where to search again. Interparallelism. Yeah, it's working, right, Aditi?
No, it's not working. It is
Then
giving.
when
Yeah.
you can send me, okay, we'll discuss this after the session.
Yeah. Yeah. Yes. Sure. Sure.
Right. So in partitioning we have discussed all this like straight flow, fan out flow. right? Fan out means partitioning, fan out, dividing the data. By the symbol itself, we can see the dividing data in multiple branches like that. Fan in flow, which is combining the data departitioning component. All to all flow. And yesterday also you have seen all to all flow having one more uses. I sent you that graph of combining the data, right? Of two partition and sending. In that graph, which I sent yesterday, it was also taking fan all to all flow, but it was not broadcasting. It was just a combining purpose. It's to all to all flow. This one, right? So here I have repartition using changing the method. That's it. It was PBK earlier. This is PBK earlier. In that, some data on P0, some data on P1, some data on P3. Okay, like you have already seen. So I have combined actually P0 and P. It's four-way or what? Yeah. So P0 and P3 data. This is P3 data, right? C101 is there on P3 because of PBK. Okay. So I give the condition in partition by expression that if it is greater than um, if it is greater than 5, oh sorry, less than 5, means C1, 0, 1, 2, 3, 4, 5, 4 up to 4, it will go to 0, zeroth, right? And zeroth partition. And then so C101 also go to zeroth partition. So it need to combine, right? The P3 and P0, that to be. So it will convert it into all to all flow. So that two, P0 and P3 getting combined. If you imagine P0, P1, P2, P3 are here, P0 and P3 getting combined and sent into P0 port here. So all to all flow is used for that purpose also. Okay. And remaining data is going on 5 and 6, that is going on P1 port. So 1, 2, 3, 4 is not there. So 1, 2, 3 is going here, 5 and 6 going on the another port. So this is repartitioning main uses in real time. This kind of uses. Changing the methodology. Earlier it was PBK. PBK is used in some graph, but here in this graph PBE need to use like that. So change repartitioning is generally like this. If you will see this kind of all to all flow. Many times they ask this question. If you want to combine P0 and P3 data, send to P0 here. So you use this method. You use a repartitioning method of PBE, and it will automatically take all to all flow because you are not combining P0 P1. Okay, two. It is four-way to two-way. So ideally P0 P1 should be combined to P0, but you are combining P0 to P3. So it will be all to all flow instead of regular reducing, regular fanning in. Reducing means fanning in. It's all to all. Okay.
Can you
So this is
one time show partition by expression, please, inside what you have written?
in nothing like C101234. I want to send in zeroth partition. So I don't have any way. So I tried to cut the last value, fourth value. So that should be less than 5.
Okay.
Right, understood, right? Okay. Like data is C101234 like that. So I just cut the last string and last character. That's it. Like this. So this is also one usage of all to all flow for combining the partitions. And then so all to all means it sends this data, make it available on all outputs. This also available on all. This also all. This also on all. Like that. That's why if we use non-integer multiple, then it make it a broadcast. then it convert it into broadcast if non-integer multiple is there. Way to two way. Well, here we converted four-way to two-way. Okay. Yesterday we tried four-way to three-way. There it was doing that all right. Four-way to three-way. These are let me check once again. Let it run, then it will depth will be shown. Yeah, this is L2, L2 to three-way, 2 to 3, two-way to three-way. Any three-way to two-way is not there. If three-way to two-way is there, then it can be without broadcasting, it's possible. Like this is three-way. This is three-way to two-way, I think. Let me check. Is it a three-way? Yeah, it's three-way to two-way. It's doing here gathering and broadcasting kind of. But if we connect some repartitioning method, then it will not do this. I think it will. Suppose partition by expression again. Which particular it is? Mm, data. I think same data we are using. Yeah. So same 106, 1, 2, 3, 4. Yeah, same partition by expression I will use here and same gather like this. That was four-way to two-way, but it is three-way to two-way. Change the name, just so much big name. Right, anything else need to change? Okay, gather, right, this one, what? Right, now it is proper. Here also it should be, So let me run the graph now. Partition by expression, three two way. I think this, okay, this took, yeah, five-way. This is also working. Three-way to two-way, then also. So in case of reducing means fanning in, we can use this kind of method. That also combine all to all flow and not broadcasting, but properly 5 records, redistribution with different method. Right. What happened? Okay, no, nothing happened. So yeah, like this three-way to two-way, four-way to two-way. Okay, if reducing, that means fanning in, then we can use this method. Fanning out, then we can't do anything. All to all will do broadcasting only in fanning out.
Vasundhara, one question. Like in the beside graph, we have written these notes like if source and destination are not in multiple. So how you have written this, like what component to use, or how we can write this such kind of
We'll
notes?
insert listen like here.
Okay.
If panning,
Okay.
then can use different partition methods. And the other will not be broadcast. Like earlier, it was PBK. Now it is PBE. Different methods. And click anywhere, it will convert it. If you want to change anything, you can property edit, change, yeah, like this, or colors and all, many things you can do. Colors is
Okay.
not, but uh, yeah, this all things.
Fonting and all those we can do.
Hmm. Then yeah, this is all about the repartitioning. This repartitioning was important concept. Like if it is fanning in, then we can do this all. Mm, for fanning out also we tried, right? But it was not working. It was broadcasting only. Fanning out means it is like three-way to two-way. But if you it is three-way to four-way, then it was not working. Let's see one more time. I have missed something. Then quickly we will check, and then that's enough for repartitioning practices. We will move for performance tuning now. So three-way to two-way, three-way to four-way. Fanning in, spreading more. 3 to 6 is okay, but 3 to 4, it's not integer multiple. How it will behave? Imp underscore 3 to 4. Um, okay. Gather is not needed. It is going to expand, so it's useless. Expanding means partition by expression is enough. Um, this can be removed, but okay, let's work. Otherwise, we'll remove it. Some error will come, I think. Let's say nothing great. 5 redistributed. How it redistributed? Let's see. 0. This is the issue. We have written the condition on 0 and 1. If we write for 2 and 3 also, then uh, suppose less than 3, so go to 0. Else, if greater than 3 but less than 5 or less than 4, less than 5. Okay. So go to 1. Else, go to 2. 3, okay, leave it. So yeah, less than 3 here, 3, 4, 5 here, 3, 4 here, 5, 6 here, remaining left. Okay, fine. So 0, 1, 2. 3 ports should be filled. 5, 6 might be, right? So remaining we didn't give condition, otherwise it could fill that also. Yeah, so that is working here, or even fan out also. In and use define partition by this thing. This method is important actually, not if only fan in fan out also. I will rewrite this entire later on. Okay, fine. So, what is the important here? Even this is what three-way to two-way. No, sorry, what is that? Two-way, three-way to two-way, and this is three-way to four-way. So this three-way to two-way, three-way to four-way. That means one is fanning in, reducing. It's fanning out. Both are working properly with this kind of arrangement. Arrangement is this. If we remove gather, then it might not work. Let's see. Uh, expanding. Yeah, expanding. All to all. We need to correct all to all, I think. Yes, issue. That's why that arrangement is matter. Okay, that this is the arrangement. In real time also, this kind of arrangement is there. For repartitioning, this is the arrangement. Mainly for non-integer multiple. Mainly. Okay, either fan in or fan out. Non-integer or multiple. This arrangement is the base. Okay. For non-integer multiple, this is the arrangement. Simple way. For integer multiples, for fanning in only partition of fanning out partition component is enough. Fanning in that what we have done, fanning in only gather, I think. Four-way to two-way we practice, right? This one here, gather component is enough.
So
Or if you want
yesterday,
to,
whatever we were doing while doing the fan in, that method was wrong. So that's why it was doing broadcasting, or in
hmm,
that case, it will do broadcasting. That is little bit doubt.
yeah, that's why this method is correct. You should use partitioning component before gather, and you should use gather compulsorily. Even you are not here, you are not using fanning in. It's fanning out, but still gather is needed here because of all to all flow. Okay, so yesterday in these methods, these are the methods we used. Broadcasting happening here because we have not used the correct method first for collecting the data using partition component. Sorry, not collecting, repartitioning it by partitioning component, then gathering it, collecting it using gather, and then sending in output. This is the correct
So,
method. These are the
so mainly when we
combination.
have to do repartitioning, we should use mostly partition by expression
No,
rather
no,
than
any component, any partition component. After that, must use gather. That is the
gather.
thing.
Okay.
Hmm.
Okay.
If you are using roll up, then no issue. It will work like gather. But if you're not using roll up or join, then must use gather. That is the thing. So repartitioning means this thing for non-integer multiple, and integer multiple is there. Then for integer multiple, we have seen four-way to two-way and two-way to four-way both. Just to we need to change if it is fanning out, then no need to change anything. Just take partitioning component. And if it is fanning in integer multiple, then just change this flow to fan in flow, the before flow. before flow of the whatever component you are using, last component, before that whatever flow is there, change that to fanning in case of fanning in is there in integer multiple, and in non-integer multiple this method is used, that will be enough. Okay, otherwise it will do broadcasting and all those all issues will be there. Now so repartitioning related that much. Then yeah, this we already discussed. Lookup MFS, what is the hash value? We have discussed this also in this class or not. Hash value means um, how the PBK works, partition by key works. Anyone knows how many record will go to if you are using PBK on department ID key? Here you have D01 till D09 and 1,000 records are there. Some belonging to department 1, some belonging to 2, 3, 4, like that. How many record will go to P0, P1, P2, P3, like this? How it is decided? Yes, guys, tell me fast so that we can move for to show you performance related something. Yeah, this we will discuss today. No idea, right? Okay, then it's using hash algorithm, like PBK use hash algorithm. Modulus 4. So it hash algorithm is what? Hash function. It give, if you give any key, it will give you some number, a random number, but same for same key. Suppose D01. First key is D01. So it generated some number like this. Okay. And what PBK will do? PBK will this hash modulus 4. If it is 4-way, then modulus 4. Like that. So modulus 4. What it will return? Any number you do divide with 4, what will be the remainder? Either fully divisible
Zero,
0.
one, two, three.
Yeah, clear, right? That's why partitions are also like that, P0, P1, P2, P3. So here, what will be the remainder if we see 1? Okay. If you divide this with 4, 1 will be remainder. Mathematics tricks. So, yeah, this D01 related, whatever values are there, suppose you have total 1,000 record, 400 records are D01. So all 400 record will go to P1 port. That is decided. Okay. Similarly, like suppose hash value of D02 is something else. So is this, it will be 0. So all the value of D02, suppose you have 200 record of D02, that will go to there. Similarly for D03, D04, like that it will calculate. Okay. So it can have same value also for suppose D03 having hash value is different, hash value will not same. It was different, something like this. But last is 60. Modulus 4. Yeah, 0. Okay. This also will go to 0 port. Like that. So these are two keys are going on 0 port. So it is not certain in PBK that how many records will go to 0 port, how many to 1 port, 2 port, 3 port. It's depending on hash algorithm. Can you pre-calculate? Can you see hash value? So yes, we have hash function. By that we can see that I created one graph. Will show you quickly and then So we have hash function. If we want to see previously pre-calculation, we want to see something like what will be the hash value. Yeah, so this is the hash value function is there. Okay, you can give combination of key, like two keys combination or one key combination. I have shown this right in this class or not? Don't know. This K1, K2 will give the different values, and that's why they're. I think I have shown at the time of joining two keys. Yeah. First one is K1, K2 value and K1, K2 combination value. Second one is only K1 value. So D01 here, D01 here. This value and this value same, right? But combination on combination, the value is different. So how to calculate hash value? That's clear. Any question or confusion here up to now? Yeah, this all we discussed. Double roll-up concept we will discuss now. Then it's in then broadcast real-time example. Okay. Broadcast real-time example is simple, like if you have in zero file that is having 32-way MFS. Okay, this is 32-way. And you have one serial file in one, then you need to join. How to join? You can't join like this directly. You need to convert it also 32-way, but by which method? PBK, PBE, which method? And this is just a very small file of 1,000 records. That's it. So if this is the condition, when your file is very small and you are one file is 32-way, which method is not sure. You don't know whether it is PBK, PBE, or PBK is on which key. You don't know, right? Then what to do? You just make all the data available on all the partitions by using broadcast. This is the real-time usage of broadcast. Right? Is it clear?
Broadcast will convert serial file to MFS file.
Hmm. As well as it will make all the data available on all the ports. So join with
Yeah.
whatever you want to join, right?
Oh, yeah, right.
Facility for big file. And MFS SK also we discussed, right? This we discussed in starting only, I remember. Next in sequence, this um next in sequence -1 into n minus or plus something. Yeah, this only. Keyboard. Yes, this is the function. Okay. For generating MFS and surrogate key, or otherwise assign key component is also there. By that also they use to generate surrogate key. One way is this, and one way is assign key component or assign key subgraph. Anything else is remaining before moving for performance? What is the two-stage routing? Yes. So we learned this all-to-all flow. Here itself, you can for saving the storage, you can do two-stage routing. Here we used to this all-to-all flow, right? Here itself, two-stage routing is also available. So if you select instead of all-to-all flow, you stay two-stage routing, then also your graph will work. And resources will be reduced. That is the thing. Resources means here there is no any resource much. Component is not there. Okay, reformat, join, roll up in middle. So 1 second, here graph is failing. Some issues coming here, but two-stage routing works. And if there are so many components, resources are there, then it works smoothly. And what is the usage of that? I will just explain that. 1 minute. Here, that just all-to-all flow convert into two-stage routing. Where to search? 1 second. Not two-way, two-stage. Yeah. So this two-stage routing, what happened? If you have suppose all-to-all flow with 25 way, then how many resources will be used as a broadcasting? 25 cross 25. Input is also 25 way, output is also 25 way for that reformat or roller for that component. Okay, like suppose you are, I close that graph. So here, instead of gather, you have some reformat component and some join component. So for all those component, input port also having, it is converted like this is some other way, 32 or 16 whatever, converted to 25 by this component. So here also 25 way and output also 25 way. So it will work like 25 cross 25 components will be engaged. Reformat or join or those components will be engaged resources. So 625. If you convert it into all to all flow, not all, then this much. And if you convert it into two-stage routing, then 2 n root n, this much resource will be used. That is the formula that it will use less resources, only 250.
Just if we click on two-stage routing, automatically it will use less resource. That's it. Nothing
Yeah,
else we
yeah.
need to do.
Exactly, but when to do this? 1 minute. When an all-to-all connect components with layout containing a large number of partitions, then the co-ops system use many network resources if the number of partitions in the source and destination component is n all-to-all flow. Yeah. So if there is a in lots of partitions are there, then only two-stage routing is helpful. If small number of two-way, three-way, two-way, then it is not that much useful. But large number of partition is there, like 25 to 25 or like 60 to 60, 32 to 32 like that, then it is useful. And when it is useful, only when you are doing all to all flow. When we use all to all flow, when we need to join, we need to combine cross partitioning data, like I shown you yesterday, east and south, or I sent you graph also, P0 and P3 need to combine. Cross partitioning combination maximum time, then only we use all to all flow. Or no, or if integer multiple is not there, then we need to do repartitioning, then also we use all to all flow. Maximum time in cross partitioning. So when I will write here better, what here, first this thing will go as it is. Like this, like yesterday we seen east west, east to south data combined to send to P0, and then in that case the components using n cross n resources. If all-to-all flow is there, but same if converted into two-stage routing, it will use 2 into n into root n. I don't have root symbols, root n. Okay, this much resources. That is the benefit we use two-stage routing. Then what is fan out, fan in? That you know already. When to use all to all. Sometimes they ask when to use all to all. So I have written here itself for cross partitioning or for repartitioning the this thing which is having non-integer multiple. Then dynamic partitioning, you guys, you can see this. You have real-time access. M partition command you see. Okay, for dynamic partitioning. Then next one, this. So we will go with one example and then we'll move for performance tuning. It is 1921. Okay. So we have half an hour. So suppose this is the data, state and Aadhaar card, phone number and all this, and we need to generate state-wise population. Like data is how sometime you receive 5 states data, sometime you receive 10 states data dump. Okay, so data is varying and state-wise population. Output is state-wise population means output should be like this. Suppose you have a dump of AP related some, this is one record, right? 1, 2, 3, 4, 5, 6,000 records. MP related 2000, Maharashtra related again 3000 record, then again AP related some 4000 records. So it's like that going on. Okay, so collect all and do a sum up like this. How to do this? And it is like millions of records are there, but some input is sometime we receive 4 states data, sometime 5 states, like that. Okay, so millions of records need to process. How to do this? This is the one use case. It can't be done simply just to take a roll up, take a shot and do a state-wise shorting and give a roll up, have a counter. Process is this, logic is this, but it's not optimal. It will take hours, right? How to optimize this? Optimize it. One solution is, yes, guys, you try by yourself. I will give you 1 minute time. Please try. Keshu. Yes. One way is like you can cut this column, right? One column. In output, you don't want other columns. In output, you want only one column. If you cut this one column in the format, only state column will go in output. Then things will reduce, right? This is one way. You can do sorting on state and then counting. Some people suggest like this also. But here's some issues there. One issue is there. If you have malformed data, then and you need to remove that all cleansing and then sorting. So either you do it that in reformat itself, that is also possible. Yeah, state and then count. This is one possible solution, actually. Another is double roll-up concept. By any case, if you this doesn't work, like either you have some this kind of data, like you need the other column as well. Okay, somehow after sorting or after somehow somewhere. So in that case, you can use double roll-up concept. So first we will do a roll-up with input must be sorted, although it is not sorted data. And make what will happen then? Graph will fail, right? So make check short false so that graph will not fail. Now what it will do? It will just collect the naturally sorted data and suppose first AP this much record, MP this much record, Maharashtra this much record, AP again this much. So it will give you duplicate data. Are you getting why it will give duplicate data? Because it is having duplicate data. That's why you didn't shorted it. So whatever natural shorted data, it will count that much only. So what is the key? State is the key, and you are doing counting on naturally shorted data. You are not shorted. You didn't short it, so it will give you duplicate. But what will be what is the benefit of doing this thing? What is the benefit? Yeah. Yes, guys. Can
The
you think and tell me?
sort, the whatever the amount of sort memory which was required, it is getting reduces because we have make check short small, sorry, false.
Yeah, exactly. Like if this memory data will be reduced a lot in the initial stage. Yeah, so the data will be reduced in the initial stage, and that will be a good performance point in the performance also. This is also one point in the starting only. You reduce the data if possible. Reduce the data in initial stage. This is one performance tips. So what is happening here? You have 1,000 records here. So AP related 1,000 record are dumped into single record. Similarly, 3,000 record are compressed, right? So it did lots of data get compressed here. That's why that is the benefit of this thing. Check short false you making and doing this thing. Although it is not correct output, but it is reduced the data tremendously. That is the thing. And then you can use partitioning method. Suppose PBK and short. That you can use the key state, and then again you use a roll up key state and some previously counted data you can sum up. It will give you the correct output. This is the double roll up concept. And many companies are using this in their graphs. Now, regarding performance, so partitioning related almost all question we tried to cover. If something is remaining, you can let me know. We'll try to cover that also. So, what is the performance tips and performance optimization practices? So best time to work on optimizing the performance of a graph is when while it is still in development, and at that time, that is the best time when it is in development, that at that time you can improve the performance. So this whole and sole responsibility of performance fall on the developers. If any issue comes, the developers are escalated for performance. Then very often poor performance is the result of bad designing decisions. Once the application is in production, it is usually too late to hope for the drastic performance. Like precautions are better than the cures, right? Then performance consideration during development. Now, over reliance on database. So during development, there are something which can be watch out so that the performance graph will give the performance. First thing is over reliance on database. There are many things that you can avoid, or you can do outside the database. That means you can avoid the database and do it outside. Like for example, operations involving heavy computation um, are usually better done with components in graph instead of doing by the database rather than database. Okay, so sorting with almost always be faster when you use short component rather than order by, or rather than um sorting in the database. For other performance consideration involvement, yeah, okay, fine. So this is also computation means computation operation means when the CPU uses more. So sorting algorithm, you need to understand there are two type of processes are there. One is compute process which eats the CPU. Computer means which do computing, mathematical operation, algorithms. So all mathematical operation algorithms, they eat CPU, right? So those kind of tasks better to do by the components that is written here. Okay, then paging or having little free physical of memory, which means you are close RAM size, physical and dynamic physical memory. uh, One second. Hard disk is physical. Just a minute, I'm getting RAM size, volatile memory. Hmm. So paging means what happened? Phases that have too many components trying to run at once, they eat up the RAM. And too much data parallelism. That also uh, data parallelism means so many components, right? They are running on the different machines, but although they are using their own resources, but still the RAM size if getting occupied a lot, in that case also paging means having very little physical memory, which means you are close to paging. Paging means you are taking the data from hard disk, storing on hard disk, also called spillage kind of problem. That similar kind of problem is paging, means taking or store in taking doing input output operation on hard disk instead of RAM. So you have less RAM, so the system started to utilize hard disk. That is paging. So when it happen, when phases have too many components, or um, too much parallelism is there. So that also we need to do smartly. The phases and parallelism need to do smartly. Then having too little data per run. So when this is true, the graph's startup time will be disproportionate um, large in the relation to the actual runtime. So too little data per run means in the starting run there is some data, then again can the application process more data per run? May it could be like read multiple file, for example, to read many little files per run instead of running so many times. So suppose you have a 60 files, small files, and you have a graph in which some reformat is used and some more transformation components are used in sending in output. So if you are running that same graph 50 times parallelly, that is not good. That will not give you performance. Instead of that, read all 60 files, combine them using read multi-file component, combine and create one single big file of them all. Means small files are there. If you connect them, combine them by read multi-file, and then run one graph. Instead of running same graph 60 times for 60 small file, run one time for entire big file. That is better. Okay, so if too much huge data, then do partitioning. Okay, but too much small data, that is also not good for the system. Because why it is not good? Because this process is running multiple times for small data every time. Is it clear, guys? These performance tips, sometimes they ask in interviews, you need to explain with examples. If any confusion is there, you ask in middle. Okay, bad placement of phase break. So what happen actually, phases, whenever the phases are there, then checkpoints are there in between the two phases, there is checkpoint get created, then the recovery file will be created on disk, right? So whenever a phase break occurs in a graph, the data in the float is written on the disk. So it is then read back into the memory at the beginning of next phase. For example, putting a phase break just before filter by expression is probably a bad idea. The size of the data is probably going to be reduced by the component. Already it's going to reduce the size of the data. So write it all? Why write it all to disk just before that happens, right? You are already going to filter it. So before that, why to write the data on the disk? So phase break means if you are giving a phase difference, that is called phase break, then it create a recovery file and it write the data on the disk. That recovery file is written on the disk. Okay, so before filter by expression, don't give the phase difference because already it is going to reduce the data. So why to give phase break before that? Phase break should be given only when there is a dependency or there is a need for run sequential, then only. Otherwise, don't give it unnecessarily. And especially before those component which is going to filter or remove the unwanted data like filter by expression. Okay, then too many shots, don't use them. Use one shot in starting, and if needed further on top of that group, you need to do further shorting. Use SWG. Okay, sort within group. So the short component break the pipeline parallelism and cause the additional disk input output operation to happen. Example of misplaced or unnecessary short can be found in the performance example graph in improving the performance of existing graph. So, so some graphs will be there which will show you how to, if you use so many short component, then what will happen. So this was the during development. During development, this all are the issue can be solved. Then there are some other tips controlling the resource consumptions and management managing the graph memory best performance, then file system layout and performance using direct input output. How many ways parallelism should you run? Okay, this one by one we'll see this. So controlling resource consumption. So, what was we have learned up to now? Just graph development, GDE related, how you can do at the time of developing. Now, how to control the resource consumption. We have seen what is a approximate memory calculation of a graph, like how much lookup is used, plus the how many components are there into 7 MB into n. N is the parallelism degree, plus max score, right? This is the basic formula of how much, a rough estimation of how much a memory a graph will take. Lookup plus max score plus component into 7 into n. This is the basic formula. Now, how to control the resource consumption? So co-op system is designed to make maximum use of the disk memory, the CPU, and all resources in accordance with the application need basis. Therefore, the especially when your application is handling large amount of data, it is worthwhile to run a system where there is as little component competition for the resources from elsewhere as competition means deadlock should not be happen for the resources. They should components should take them one by one, and as much less resources they should competition should not be there. That means suppose you have 100 GB RAM, right? One process can take 80 GB and complete its task. Another process can take 80 GB, complete its task. You have only 100 GB, right? So don't run both of them in parallel. They will create deadlock. Run them one by one. They have high memory. Their do addition 80 plus 80 160. So it is not um like it is less than the it is more than the RAM, total RAM. That's why give them a sequential run. Don't run them parallel. Okay, if their sum is less than RAM, okay, not equal to, if equal to also there, then also run in sequential. Suppose some job need 10 GB, another job need 20 GB, you can run them parallel, no issue. So try to make less competition for the resources. Often it is possible to improve an application's performance by increasing its resource consumption if the extra resources are available. Yes, you have many machines, you have 12 machines, you can use 12 way. You have 30 machines, you use 30 way. Okay, in otherwise, yeah, don't do parallel otherwise. If other items, it can be necessary to reduce an application's demand on resources in order to get the best performance, yeah, because of the activity of other application or because of the reduction of ability of the resource themselves. Okay, fine. So what is the resources we have? We have RAM, we have hard disk, we have CPU, three things, right? So how to reduce hard disk resource consumption? Right. So you can control this by making a multi-file and making it a multi-file, use and splitting its partition among several disks. Like use 4 5 machines and do 4 way or 5 way accordingly, and distribute that data into those create a partition, right, on 4 way on 4 different machines. They will have 4 different hard disks, so that MFS will eat up their data. Means they have their own separate resources, their separate hard disks. Breaking the data up into the smaller separate data sets, that also useful for this. For this is for a large data set to a moderate data set, not to be too much small. Okay, compressing the file, that also help, like ICFF we have seen. Then controlling RAM. So RAM you can use. RAM is very important for every. So max core management come here, right? We have discussed n number of time for this thing, RAM size, max memory, max core, everything we discussed many times. So choose this thing, choose the max core settings wisely. We know this, reducing the level of data parallelism. So each additional partition of component requires space for additional components processed in memory. Reducing the number of partition, reduce the number of uh, component process. So it is reducing the level of parallelism means, see, if you are increasing the parallelism, then increase the RAM also. Better. If somebody can spend on 30 machines, then they can spend on few RAM also. That is the meaning. If somebody is not spending on many machines, then don't do that much degree of parallelism. See the customer also. Reducing the number of components in the graphs, largest phase. Largest phase means there is a one flow running like in a say in a one phase, and your number of components should if they are more, then that phase will take that that phase will occupy a lots of RAM, right? That's why phases means sequential. That's it. Opposite to parallelism is sequential, one by one. So phases means one by one. So if you are giving phases, that means in one particular phase you are running if you are using a lots of components, that is not recommended. Use less component in a one phase, that is recommended. The peak memory consumption of a graph is determined by the memory consumption of its biggest phase. Okay, so why it is because uh, there are four phases, for example. One phase is occupying 100 GB, remaining phase occupying 80 GB, 50 GB, 20 GB. Okay, so what will be the memory consumption? How much it should be available for the system to run? How much? 100 GB. Otherwise, first phase will not run at all, right? But if your phase is first phase is occupying less, like first phase is 100 GB, second is 20 GB, third is 50 GB, fourth is 10 GB. So instead of that first phase 100 GB, if you will keep it into five phases, first phase less, reduce the number of component. First phase having taking only 60 GB, and that 100 GB phase you divided into two, 60, 40. So first phase 60, then 40, then 50, 30, 10, like that, five phases. So maximum RAM size, what will happen for this graph? 60 GB only, right? So 40 GB RAM is saved, can be utilized for some other parallel running process. That's why they are saying that biggest phase should be try to reduce number of component in biggest phase. That is the rule of thumb. Okay, then if we note down here, suppose performance tips for memorizing. First, reduce the data in initial stage by filtering unwanted data or by compressing by rollup. Second, compressing means this word is misnomer, by reducing. Second, uh, small file size. So many small files in every run is not good. Better to combine them using RMF and run in one run. Many run of small file versus moderate file single run. Okay. Third, this thing like biggest phase, reduce number of components in biggest phase. What was this? Many small files, multiple run versus one moderate file, single run. Second one is better. Okay. Then don't use phase break before filter by expression. Use phases wise. Use phases wisely. Fifth. Why? Because each recovery file store on disk. That's why. Then max score, right? Reduce the specified value of the max score parameter if any component that has this parameter, max specified amount of RAM. So optimize max score should be optimized, and reducing the level of data parallelism. That is this term is, instead of reducing we need to use wisely, so that it can, if you have number of machine, you can give good RAM and can give that much data parallelism. Data parallelism is depend upon you how many machines you have. If you don't have, if the customer is unable to supply, then don't go for that much data parallelism. Taking the advantage of shorted data by using component with shorted input, set to input must be shorted or mm, grouped. Component that process shorted input use very little memory compared to what would be required to short the data. Yeah, they are saying don't use in memory. Okay, in the short. So that process shorted input use little memory compared to, if you say in memory, they will require more memory. So use the short component wisely in starting. Use the one short component in starting. One short component in starting only wisely. Sleep. Avoid many short component and try to avoid in memory. That is the meaning. Then CPU uses. Use the throttle, right? CPU related, computing related things are there which use computation. So already it is said that for computation work, the task which use computation, which use CPU for computation work. Abinitio is famous for high computation work, like algorithm. Sorting is also algorithm, and a mathematical operation, complex expressions. These all multi-stage functions and all. These all are computational work things. So first thing is task which use don't rely on database for computation work. Use the component. First thing is it. Even it is also recommended PDL also. Don't use SQL query or high computational work on PDL level. Use the component. They should be used for lightweight things. Then throttle is for regulations like heart bit regulation, like that. It is bit rate regulation of the data. So these components allow you to slow down. I shown you this rate, bit rate per second, right? At which record are processed through a flow. The CPU get less work at a time from the graph and more time to spend on other tasks. So reducing the data parallelism is good for this also. Reducing means I have written here the meaning of reducing. If you have, then only, otherwise reduce. So yeah, use the throttle for bitrate regulation so that CPU will have some relief. Optics virtual memory facility will page part on the component's memory and to and from disk in a very insufficient with lower max core value. One that eliminate virtual memory paging, the component will work within a smaller amount of it will move the data to and from the disk, so it will cause the spillage. And max core is set to the value larger than the amount of the physical RAM. The operating system's virtual memory facility will page parts of the component's memory to and from the disk in very insufficient way. Insufficient because the operating system has no way to understand the pattern or access to the memory. This is the answer of what will happen if you give high max or low max. Okay, a very point to point answer it is. On consider a multi-file that has one or more of its partition on a disk shared with a disk intensive application. Single disk application is shared, then worst case. That's why I'm saying if you have more machine, then only do parallelism. Single machine, don't do parallelism. Multi-file with a fewer partitions and thereby avoiding use of a disk could actually be performance. Yeah. So if you have single disk only, don't do that much parallelism. So this is managing the then managing the graph memory for best performance. Um, Graph memory. So mm, memory needed, how much working set, physical memory, how much RAM size they eat up like that. So here a graph performance, managing the graph memory for best performance. A graph performs best when the total of memory it need can fit completely within the amount of physical memory that is available. That means utilizing the entire memory properly. The total amount of memory of a graph means biggest phase or any other program need to accomplish what is called the working set. So suppose you have two components and they are using some working set memory in this much and this much and this much, and that is occupying here, right? So this much is free, right? So you can increase the max score little bit for occupying. So you need to consider RAM also. When you are increasing max score, you need to consider available RAM. Available RAM. Okay. This RAM is this is the total RAM. Okay. Suppose 10, 20, 30, 40, 50, 60 GB RAM. In this 60 GB RAM, this 10 GB is occupied by first component. This 20 GB occupied by the second component, then 30 GB is remaining. So if you need an increased max score, you can increase till 30 GB like that, depending upon much more factors. So fitting your graph in available memory, how does single graph use memory? I have already told you that all. Calculating a graph's phases, memory uses, formula to calculate a component's memory uses, memory need for lookup file, choosing the max score setting, calculating memory uses, an example. So um, this is one graph having lookup, having format pb k or pb whatever, then roll up and short. Okay, this and then output file. This is the component. These are the components used. So what is the memory occupy? So what is the size of lookup? Then if it is if format component product lookup file, okay, then index size lookup file key parameter as product input file, then 1 million. We are using a 64-bit system, so since the key is simple fixed length type, so 24 byte per index entry. Phase 0 of the graph memory consumption, total this much, 227 MB they calculated. Phase 1 of the graph consumption. Phase 1 it means this is phase 0. Phase 1 is this two. So how they calculated this two phases memory? 227 and 214. Short and roll up. 1 second. 21 MB by other component. Three components are there. In phase 0, three components are there. So three components occupied 7 into 3, 21 MB. Um, Other means trash is also there. So 1, 2, 3. This three component. Roll up has occupied 142 MB. Okay, how roll up occupied 148 MB? We'll see that. Above calculation is there. Lookup is occupied. This size is 64 MB. It's occupied 64 MB. That's why total this. Then this max score. So what is there then max score? With max score, it is occupying 214 MB. Okay, this short component in one phase. So total you can calculate like this. How much component into 7? 7 into 3, 21 plus this roll up having max score also. That's why. And plus lookup. So here 142 of roll up, right? This one. 64 MB plus 7 MB, 71 MB into 2 instance. By 2-way it is. PBK, it is 2-way, I think. This output is 2-way. That's why. So roll up is 2, short is also 2. Okay. That's why 64 MB is max core. 7 MB is component size, 71 MB into 2, 142 MB of roll up. And short component is also 100 MB max. 7 MB 107 into 2, 214. So from where this 214 and 142 come? Is it clear, guys? This memory calculated? Is it clear? This is for two roll-ups. Okay. And this is for two shots. 100 plus 7, 107 into 2. This is 64 plus 7, 71 into 2. Okay. So this is how we calculate roughly a graph memory. That is, sometime they ask question how to calculate the memory of the graph. Then, mm, yeah, file system layout and performance. Layout also matters. What is layout? Layout means the depth or the um, files, file systems. Mm, What determines the read-write efficiency of file system is the number of independent disk controller and disk available and whether the files are cached in the controller. These things are often hidden. However, beneath the configuration file system, for example, within the storage area network, saying it depends on the many things. So the simple test described in this section will give a good idea on the performance capability of file system. So there are three things separately measured: write performance, read performance, and write and read performance in same graph. File system performance testing should be begin with the serial operation. This give you a set of simple observation. You can then go to the test parallelism on MFS with a succession of MF multi-files using increasing number of partitions when testing the performance of a system or an application in various scenario and configuration. It is critical to change only one thing at a time. That way, you will always know the precise cause of any performance change. Like first you run first on serial, then increase the partition number of partitions like that. Graph work best with an application file space that is optimized for reading and writing large contiguous block of data fast. Reading writing operations are not using any CPU generally. They are just accessing some either you are reading from existing location CSV, DAT, okay, or you're connecting some database, fetching the data, or you are using some API and reading the data from there. So that is not using CPU, that is not computational work, but the operating system threading and all that is involved here, multi-threading and all. So here, this thing, file system layout and their performance, application that is optimized for. So how to check this? It is depend on operating system. So we don't have any particular for checking that. Like CPU has, if you want to check the CPU, we have that speedometer, right? View, it doesn't work here, but it is there. Like this speedometer is there for CPU. CPU uses for computational. I don't think it will work here for very small process. Yeah, it doesn't showing anything. But this is for CPU, not for anything. And tracking detail, we can track RAM and hard disk health, CPU health also by tracking detail. Also, we can check CPU health. But input output file operation, we need to see how we can check by one successive run serial, then increase the two-way, then four-way, how the graph is performing based on that. Next, using direct input output. So, I'm not going to go in this much detail. Next is how many ways parallelism should you run? Yeah, as this most other good thing, it's possible to have too much data parallelism in a graph, but data parallelism consumes additional resources. And if you don't have, that's what I told. If you don't have the resources to support the degree of parallelism, if you have specified, your graph performance will be worst. So that's why what to do, if you have machines, many machines, you have enough good RAM, then only go for degree of parallelism. Otherwise, tell the customer that no. The kind of parallelism, what happen as you keep increasing the data parallelism, find the right degree of parallelism, increasing the parallelism of a graph, exceeding number of processors. Yeah, right degree of parallelism. Um, so different operating system like Solaris, AIX, HPUX, right? For them, what are the different processors are there, and based on that, you can work to look for the tracking data for CPU usage and all effectively. Based on that, this is the task of who create the parallelism, like the TM, now TM administrator team. They people used to see this all and resources and all, and they only create in real time. Also, developer have that access that okay, this is 32-way file, you have 32-way layout, use that. So but who will decide that what should be the degree of parallelism? That is all decided by TM administrated teams. Exceeding the number of processor, that's good only. For computational task, high degree of. So there are situations when it can be beneficial to performance to have a high degree of parallelism in a graph than processor on the then there are the processor on the computer. The extra parallelism can give the operating system greater flexibility in slicing the job to the more among the process availability, and does allow to make more efficient use of processing power. Hmm. Since there is only one CPU available and a single CPU can do only one thing at a time, threading issue, then it will take the two components a total. Then so CPU also making the sense like let's move the computation to two CPU machine. That so this improve the things with pipeline parallelism at work. The two components will be able to do their work more and less simultaneously, and total work now be completed in 325% reduction in the time. So if you increase the CPUs, then computational work also will. And in what matters in degree of parallelism? So I have written here data parallelism depend on the machine number of machine. Machine means machine have three things. Individual machines, hard disk, mainly three things. It will have many things, but this three is impacting things. This three will be increase. If you have n number of machine, that much parallelism you can think for, and good amount of RAM. Yeah, apart from this, any other performance tips are there? So you can use like basic tips like don't use that replicate, right? Replicate, yeah, one important question left. So what is the difference between replicate and broadcast? We will come that. So don't use replicate unnecessary, like replicate on just after input file or intermediate file or rip format. This is one thing. Ninth, use implicit reformat facility. Use implicit filtering facility like input select, output select. And implicit reformat is also available in all the components. Yeah, right, use it. What is the difference between reformat and replicate? I think somebody asked me this question, right? Long time back. Reformat versus redefined format. So answer is that first thing, um, this reformat versus redefined format, right? A reformat used to rebuild the things, occupy the memory, and rebuild the structure, rebuild the format. And redefined format doesn't occupy memory, and it just uh, combine. It doesn't rebuild the format. Like reformat transform. Okay, reformat occupy more memory. 7 MB is common, but reformat has transformation logic also, so it occupy more. And it doesn't rebuild structure or format. Just adjust. It just adjust adjacent format. Memory location or combine memory locations. That's it. Okay, but in string concat, it will rebuild the format or yeah, like rebuilt format new object. This is the difference. Then broadcast versus replicate. So answer is same like it's used for data parallelism. Replicate used for component parallelism. That is general usage, although both can be used interchangeably. Broadcast can work like component parallelism, replicate can work like data parallelism. They both can do with each other's work interchangeably without any issue. Replicate can do like partitioning. It can also do like partitioning component. Broadcasting, it can do broadcasting. Broadcast can do replication. Both can do their work in it, but they are used for a particular purpose only. That is only the thing. Other than that, their functionality can be interchangeably reused. Okay, so when used, broadcast replica, asymmetric component replicate is generally used to increased component parallelism. Um, broadcast is used for data details. Very similar component in both a copy each other's record to multiple downstream parallelism. The only difference between them lies in how their flow are set up and their layout are propagated. Basically, broadcast is treated like a treated. This is the term. Only treated. This is the only difference. One word, treated. Really. Otherwise, they both can do each other's work. This can do its work, but they are treated differently. That is the only thing. Treated means they standardize. Treated like a partitioning component and define the transformation of one layout. Replicate allow multiple output like work as a component parallelism. That is written using the default. Yeah, everything written here. They can. I have checked also. They both can do each other's work interchangeably. Right. This is the only difference. So with that, it's done. Now you can go 1 hour lecture in this. You can go on defining data parallelism. You go on defining the component parallelism. Lots of things are there. I have given actually 1 hour lecture to one person who was very new voice and he want to learn this difference only. He doesn't know data parallelism. He doesn't know component parallelism. He want to learn only difference. Then I need to give 1 hour lecture to him for just 2 lines, making him understand everything. What is parallelism, data parallelism, component parallelism, pipeline parallelism, everything. Okay, guys, so we have completed here. Partitioning related maximum question we done, repartitioning related also. Then performance tips also done. What is the remaining upcoming topics? I will just list out and we'll close now. Yeah, 8:17. So upcoming topics are like what is remaining here? Partitioning done, then PDL remaining, meta programming remaining, that we will do tomorrow, and then uh, conduct IT and plans, plan loops, then continuous component, air command, M command, code migration, Unix command. Yeah, this much. Pset and parameter evaluation. Right. This much is remaining. So within a week it can be completed. 5 to 7 days it will take.
What about project?
We have covered SCD1, right? SCD1, SCD2, ICFF, and uh, I will show you tomorrow one star model. I have one graph for that star model with assigning key component. And we have covered lookup also. Lookup with small this thing. Lookup with some one small project of lookup we have covered actually. And this thing normalize we have completed, but vector flattening related one project was there. Which one it is? Mm, This thing we already done. Okay. Vector flattening, JSON, and how to read the JSON file. Vector flatten related one inventory management project that I will show you. Actually, this just we have discussed many things about this related things, but I will show you this one. Header trailer, how to add header trailer, we covered or not? Add and removing header trailer we did. Add header and trailer. That is one. Sometime in projects they cover this thing. Then JSON file reading. This I will show you. These things I will show you tomorrow. This already we done. Unzipping. There was one more project was there. I need to recall that unzipping file and all. So, and housing, unzipping file, then processing, then housing work. This is a complete end-to-end flow of graphs. Yeah. So this may take few more days. Like if we will show all these things, then it may take few more of 7 to 10 days for completing everything. Okay. Anything else? Okay, then we'll conclude here now. We'll see you tomorrow. Bye, everyone.
Yeah, bye. Thank you.
Okay.